Hi, welcome to this demo of Lab 10135 for CCNA3 routing and switching, scaling networks from the routing and switching curriculum. We're starting with this topology. This is the topology we'll be working with. I'm working, of course, straight out of, actually, let me move myself over here for a minute. Yeah, we are working right out of the PDF instructions which are in Netacad. You could also build this whole thing with Packet Tracer. Sorry. Oh, wait a minute. Have I already done this? Hold on. I could be doing this all wrong already. Oh, sorry about that. I had a moment of confusion, and I wanted to make sure that I hadn't actually done this already. I haven't, as the topology you see in front of you suggests, and this config does too. So let me move myself back over here. I had actually done the other live lab for Chapter 10, which concerns OSPF routers in a common Ethernet LAN segment, and what that means in terms of designated router and backup designated router selection, and how changing the router ID changes that, and priority, and so forth and so on. If you haven't done that lab yet, if you haven't watched that video yet, go for it. What I'm going to do now is OSPF v2 advanced features, this lab here. As you can see, we've got our simple 3.3 edge mesh, all three routers talking to each other. So it's not as if I have to have router 2 routing in order for 1 and 3 to talk to each other. I've got 2 simulated networks, and I've got a simulated internet. So of course, as usual, the first thing I'm going to do is my basic configs. And again, as usual, I have already written all of that. Once you get familiar with this process, you should probably be able to more or less read the instructions, write all the config code within probably the space of 10 or 15 minutes. If you really want to walk through it one step at a time, this lab will take a little bit longer. If all I wanted to do was just make it happen, I could probably drop these configs right now, and this demo video would be over in 5 minutes. Of course, that wouldn't be all that interesting as a discussion of what we're doing. So let me get started. I've got my router 1, and I got my code. Of course, this is my friend Notepad++. What I'm going to do, of course, is take my router 1 code, and I'm going to go down and stop there. Sometimes, actually, you know what, I'm going to stop here. I want to make absolute, and actually, I don't need that config line. I want to make Control-Z. I want to make absolutely certain that I copy the super basic configs on these things first. As with any configuration like this that you're going to be doing any kind of complexity, it is a really good idea to copy, run, start repeatedly. And of course, in the real world, you would also be doing that. I know you've probably gotten out of the habit of doing it in the lab, because the last thing we want to do is lock ourselves out of these devices and waste precious lab time resetting the routers. But in the real world, whenever you make an important change, save your state. So, and router 3. And of course, I'm doing the same stuff on all of these. It's part of why I'm blasting through this so fast. This part of the process should be second nature to you by now. So let's start on the fun stuff, the interface configuration. So going back to router 1, I've got 3 networks. I've got my serial 000 going to router 2. I've got my serial 001 going to router 3, and I've got my gigabit network. And I have documented all of them. Of course, I'm going to start this with a config T again. I had to get all the way out in order to do copy run start. There. And likewise, oh, hold on. That's a problem. I'm on the wrong router. You know what? I'm going to reload this. Okay. So while router 3 is reloading, let me put this back on router 1 and do this right. And now the thing that told me I had gone wrong was that this link light, shall we say, over here came up. I wasn't expecting that. I was expecting this one over here. Like that. Always, always, always. You need to understand what you expect the outcome to be so that you can catch problems when they happen. Boom. Now, one thing I want to note here is copy. So I'm on router 2, I'm creating a loopback. And notice that my link between 1 and 3 has come up. Now, finally, I can go to router 3. Okay, so router 3 is back up, and I need my interface configs. Now, so the first thing I want to do, now I notice that it's probably not working because, well, the interfaces are down. Do show IP interface brief. Okay, everything's administratively down, that's fine. So I can take my config code and drop it in, and boom, my network lights up. So the last thing to do here is actually, because this is something you can't pre-code, really, we are going to go to our devices and do static config on our end hosts. And we do the same thing over here. Of course, PCA is in network 1 and PCC is in network 3. Okay, so there's that. There's a couple ways to test all of this. And one thing I'm going to do a little differently that's not listed in the lab, I'm going to go ahead and turn on CDP everywhere. So I can then do show CDP neighbors and confirm without actually having to ping. Actually, and really and truly, I should ping. But I want to look at neighbor 2 adjacency, then neighbor 3 layer 3 connectivity. Sorry, layer 2 neighbor adjacency with CDP neighbor, layer 3 connectivity with basic pings across these lines, and then, and only then, are we going to add OSPF and watch it build its neighbor adjacencies in the application layer. Of course, the command there is CDP run. And let me do the same thing on. Okay, now I can do show CDP neighbors. And I see router 3. And, okay. Okay, let's see if this, now, it's possible that CDP is taking its time coming back up. Do show CDP neighbors. Okay, router 1 and router 3. Yes, that's good. Do show CDP neighbors. Boom. Okay, that is a problem. Okay, router 2, router 2. Okay, router 1. Okay. Router 2 and 3. 12 and 13. And I see 13 and 23. Yes. Okay, there, that's better. I was getting worried because each of these devices should have a layer 2 neighbor relationship with each of the other 2 devices. If I had seen only part of that, that would have been a major cause for concern and a deal breaker as far as OSPF is concerned. So do ping 182.168.12.2. Do ping 182.168.3.2. Boom. Okay. So I'm actually going to do ping 182.168.15.1. So what I did here, I pinged from R1 to R2 on 12.2. Then I pinged from R2 to R3 on 23.2, going down this way. Then finally, I completed the circuit by pinging around from R3 to 13.1. I don't have to ping every address both ways, but I have confirmed that I've got layer 2 and layer 3 connectivity all the way around the loop. If I had had an address conflict or something like that, this would not have worked. The final thing to do, of course, is ipconfig. Ping 192.168.1.1. Have your clients ping their gateways, so that before we start any of this OSPF stuff, we know for certainty that everything is copacetic at layer 2 and at layer 3. And I'm good. So I have, this is essentially, so I'm good and done with part 1 of the lab. The next video I'll cover OSPF routing. We'll change some metrics, and then we'll finally configure a default static route. Now, I created a route, a loopback to simulate a static route on R2. But we're going to talk when we get into that about how I'm not advertising it into OSPF. There's a right way and a wrong way to do this. So I'll be right back.